Hello class, Dr. Mike here for CIS-2640 Network Security/Security Plus on the topic of authentication and account management. This is at the time of this recording, chapter 11 in the textbook, and it is week 11. Again, always check with your current syllabus and shell for any changes to that. So the textbook itself, it is authentication and account management. We'll go over some of these topics here. I'm going to really just highlight a few things and show you some good external resources. And then, of course, we'll come back, look at the summary, make sure to miss anything. So, authentication and account management. Authentication, definitely something that we've all ran into even before you even started college. It's the normal ID password, right? Let's put ID and our password. So this is basically what we refer to as, we have multi-factor authentication. This is first factor. First being something you know. Now, of course, we know the ID. This is some form of a unique identifier, an email address, a user ID. It could be other things too, though, but we'll take that as our most common one. And username password is definitely the most common, and also could be the most troublesome for security, and for a lot of reasons. We'll see why. So something you know is our first factor. Now we can add to that, and we can see something you have, and this is called second factor. So ID, password, and then something we have. It could be a key fob, a mobile device, so it could be a mobile phone number, or an email that we receive, of course SMS, code, or a code over email, some sort of code, right? And we see this with a lot of applications. Will send you over text that, or even like right now, Star Wars: The Old Republic game. There's actually an app on my mobile device that will give me a code. So this code is our second factor. It's sort of a way to verify that second factor is what it is. So again, the code itself is just a way to verify that we are who we say we are based on this second factor of something we have. So again, something we have, something we know, first factor, something we have, second factor. There is a third factor here we can do, and that is something you are. And this, of course, would be a fingerprint, fingerprint recognition, facial recognition, biometrics. It's referred to as a third factor. So, if anything, you'll see, and we're going to see in a lot of places, second factor authentication, using something called MFA, multi-factor authentication, which usually refers to this. And this is the most common, and definitely a plus. There's a lot of pluses to this. There is some administrative side. Of course, you need to install an app. If the phone gets lost, I don't have the app. And yeah, there's ways to recover that app or set up a new device in my account without having a device. And that's when we go back to some sort of customer support, which, yes, can be hackable, right? If I can tell someone I am who I say I am and I have a new phone number, somehow prove that, maybe with a credit card information or information gleaned from passive reconnaissance, social media. So yeah, it is not foolproof, but it's going to help us with this right here, this password issue. Now, this, what third factor brings in, it brings in some ease of use. So I can have a strong passphrase on this device, but the typing each time is cumbersome, and most people don't like the idea of a cumbersome every single time I open this device up. So the fingerprint authentication, boom, it opens it up, I'm in. And that's good. That's going to make the first factor stronger in a lot of ways. So I can have a stronger passcode by making it ease of use with the third factor. Now there is a fourth factor here. I don't know if they bring it up here on credentials. There's a fourth factor, and it is sort of where you are. And we've talked about this before. Geometric IP gating, An example of this is password management. So I know like LastPass has a feature where they don't allow access from an IP range within like Ukraine or in China or areas that are known to be hives of either hackers or hackers using VPNs to these IP ranges. So geographical, maybe using GPS, some sort of geographic fencing it's called. Another example is maybe I have an app I open up that does not allow access unless I am on a certain Wi-Fi network. And that Wi-Fi network being maybe on an organization or institution. So there's a way to bring that in. So those are the different factors to look at. And let's talk about the reason why we have those factors, and that's because of passwords. It is the most common authentication today, and it also is the most attackable and usually the weakest because of us, humans. So passwords are the weak links, and long complex passwords are definitely the way to go. No surprise, a long password, a random password, it's going to be harder to crack. And I say crack, we'll look at that in a second here. And really think about it. It's called entropy. It's actually a physics, thermodynamics, I believe, which is the degree of randomness. And you want that in your passcode, passphrase, password. And the length itself actually does link to it. Now, I can make a password 123 with ... period, or 123 33333. That is going to be better than 123. It is longer, but it still has limited scope. And I say by that is this. So let's look at what we can bring in to bear on our passwords. We have a lowercase a through z, right? We have 28 characters here, alphabet. As soon as I bring in uppercase, I now have another option of, it's supposed to be a z, another 28. So I just doubled my entropy pool. I say entropy pool again, it's because we need to guess. What do we need to guess? Talked about this before in previous chapter about, of course, your example, 0 through 9. If my passcode on my phone is only 0 through 9, well, that's, we have 10 things we need to guess. So it's a small pool. So example for a mobile device, if I have a passcode, and I don't know if they changed it or not, it's been a while. Mine I've used a longer passcode for a long time. But it used to be on the iPhone screen, it shows a keypad with 4 dots. Well, right away it tells me it's 4 digits, and I know it's 0 through 9. So it literally has this set my scope of my attack. Whereas if I add in a lowercase a to that, now it becomes a passphrase. And my screen just shows a big text box and a keyboard. And now, as an attacker trying to get into this device physically, I have no idea now. Is it uppercase, lowercase? I know now it's no longer 0 through 9. It's something else. So expanding that, it's bugging me. I have a better Z there. Expanding this pool of entropy is going to help out. Now our special characters, well, let's add space. If you allow spaces, it's the old space bar here, right? That, of course, adds one more. And it depends on how you handle passphrases, and it should be handled securely. It should allow spaces. And then we have special characters, right? We have, of course, the dollar signs, pound signs, percentage signs, the @ symbol, these special characters. And I believe those, in my notes here, we have 32 of these possible. So that's a 99 pool of randomness. So, which is going to make this go from, let's use our 1 through, our 1 through 0. We literally have gone from 10 to 99. So we've increased this randomness. And you can test for this. And this is an example. This is from GRC, Gibson Research Corporation, a great resource. And you can test out a password. Password, I can see it's space, it's depth, it's 26 characters, 26. We have 8 characters here, and possible online or offline attack. Of course, password known being really bad. If I do password 1, now it's actually adopted. Now still, we look at password attacks are different. We're going to bring this out to bear, but just the fact that we've increased the depth of this. If I put in a pound sign, it's made it larger. I make this uppercase P. Now we're in weeks. And still, this is not a good password. It does bring in uppercase, lowercase, a digit, and a symbol, which increases our space. So in this case, they call it the search space analysis. I call it entropy. And it's pretty obvious. It's common sense. It's hard to guess. Now, again, if I add a dot, 2 dots of that, because I've increased the depth, in this case 95, it's going to now, it does thousands of centuries, whatever. And these are just sort of rough calculations. But the important thing is, even if this contains the word password, which we know is not a good password, but by adding this and it's uppercase, I've made it harder to guess in certain attack scenarios. So the idea is don't become the low-hanging fruit. And usually what will happen is you have a data breach. We'll go over good password strategy here. One, of course, being different passwords to different sites. Second is a strong password. So let's say I'm a part of a gaming site, and this is my password for that gaming site. And that, of course, that site has bad security. It's breached. Passwords are held. Maybe just the hashes. For every case, the password gets out. Right away, I'll change it. But second, if it's, let's say they're held semi-securely, they can go through and try to hash, break the hashes with some sort of offline attack. As an attacker, if it takes, let's just 1.74 centuries, let's say. So let's say, that's probably low and realistic, but let's say it takes months of processing time to break my password. I'm just gonna move on to the next one. Find that low-hanging fruit. Because I'll use those for other attacks. So again, they should be unique for each site. And there should be some sort of password policy in place. This goes back again to administrative and security policies, written policies, training, and verification. So we should, of course, enforce passwords if possible, and that's a technical aspect. Of course, on the server itself or my device, I set up a policy, Active Directory policy. We need to have a password that's over 8 characters, 12 characters, 1 uppercase, 1 lowercase, 1 digit. So we can enforce that, and we can have a written policy to sort of back it up. They say don't use the same password in multiple places. So you can see that you need to have written and technical ways to go ahead and enforce good passwords. Weak passwords is that I don't think we know we take shortcuts. There's the hacker, replacing certain things, like replacing L instead of LEET1, and replace C3T. There's that hacker speak and things like that. Unfortunately, this stuff's already been known. There's dictionaries that have these already pre-made. And we'll talk about the attacks here in a second. So again, here's an example, the rank of passwords. So I can get those passwords. Social engineering is probably the first one. There is, look at my notes here. I've used myself CUP, which is a password. My notes here, my old RTFM manual. CUP is a password. I think it's a Python script. CUPP. I should have brought it up for this lecture. So if I'm doing a pen test, I'm going to look at all my targets, and maybe I'll focus my targets into specific people, maybe marketing managers, maybe accounting managers. And again, not trying to stereotype anybody, but people I don't think are going to have the forefront of keeping security in mind. And being a marketing person, they want to be out on social media. They want to meet people to know about them. Well, shoot, I can figure out where they went to college, their spouse's first name, their pet's name, their favorite movie, their favorite book. I feed this into, I think it was CUP, feed it into CUP, and it'll come up with a dictionary of possible passwords. So information about it, this is the social engineering aspect. This is the pseudo virtual dumpster diving, which I can create a phishing attack, maybe get some attention and capture them over a keylogger. So again, there's other vectors that can be used to get those passwords. And the reset attack, this is a good one. When evaluating your password strengths for your institution or your company, or you're being paid as a pen tester maybe, or you're doing an evaluation as a security consultant, look at how they reset passwords. that uses the weak link. You have a great, maybe you have a really good way of sort of securing the passwords correctly, and we'll talk about that in a second. You follow the best practice for securing them. However, your password reset policy is, guess these 3 questions. And this has been shown in the past. The governor of Alaska, I think it was Sarah Palin, her Yahoo account was attacked. You think it was a sophisticated attack? Did they come in using some sort of NCIS looking screens? No. They basically looked at the wiki page for the person and found out, I think it was their anniversary or their anniversary date, and that was the password reset question, which is a weak reset. So, and even then, password login pages. If I go to a password login page, I go to a login page, I put in a username Mike and I put in password test and I hit go, and I know it's wrong. And so again, approach this from the attacker's point of view, and it comes back and says, "I'm sorry, that password's incorrect." Okay, I put in Dr. Mike and test. It comes back and says, "I'm sorry, that username and password are incorrect." You see what I'm doing here? I literally can leverage your site or our own site to figure out a list of usernames. And there are username lists out there. I have a bunch of them on my laptop here. I'll just feed through and find the ones that come back and say the password's incorrect, but then they said the username's incorrect. Use like Burp Suite, I can automate the attack, feed that to a CSV file. I have a list of now usernames. So it's those little things like that that slip by. That's part of the resetting attack. So attacks. Most attacks are going to happen offline, though you can do these attacks directly with a website. Will be an online attack. Offline attack would be if somehow I get a database of passwords, maybe through a SQL injection, and I can crack them. You want to crack those offline. You can bring more power to bear using GPUs and Hashcat, for example, and that's using a rainbow table attack. You can try to basically get those passwords, and then you have username and passwords. And then, of course, the idea being, if someone's username is their email, is that same password used for their email account? Again, back to password, proper password security, which is don't use the same password in the same place. So, again, offline attack probably the most powerful. Offline attack also we can do different things. In an online attack, let's talk about 2 things here: brute force and dictionary. This is something that gets confused a lot. I run this in a lot of my classes, and right away, brute force. Oh, it's brute force. Well, brute force actually is algorithmic. It's actually using this. It's saying, hit this website. Hit username. I know the username Mike works because I used that attack. That attack method before. And for the password, I want you to go ahead and do lowercase a through z, and then uppercase a through z, and then 0 through 9. And start with A, B, B. Now, this is an algorithmic attack. This is called a brute force attack. And it is usually not the best attack to approach. Now, let's say, example, I know they use a passcode, maybe some social engineering, and I know it's only this. Well, then, yeah, go ahead and try it, 000 through 999, and all combinations in between. You can see these are very lengthy attacks, very noisy. But this is an algorithmic attack. So that's brute force. Brute force referring to brute force different patterns in. Now a dictionary attack sounds the same way. You think, well, dictionary is using brute force. Well, it's forcing different things into this field, but it's getting from a file of passwords. And it can be usually like mine, I have like the first top 500 worst passwords. Password 1, 1, 2, 3, 4, and so on. And then maybe I have some custom ones I append to this file, create my own dictionary. This is a dictionary attack. And by the way, let's see, I should have had it open for this, but weak pass, for example, not to advertise the site, but I can go here and download. Here's online brute force. It's got 2, it says. I can find word lists easily. Weak pass 2A, and these are pretty big, 84 gigabytes. Here's an example. That's a big dictionary, 85 gigs. But yeah, or if I want to copy these and put them into a dictionary, just do that. So weak pass, for example, I can go and find these. I can find previous password dictionaries from like LinkedIn attacks. They're out there, and I'll use these in my dictionary. And the best thing is if I can do some sort of reconnaissance work and figure out maybe how the password is being used, especially for this user, I can customize using like cup my dictionary. So, but dictionary attack and brute force attack are different. Let's keep that in mind. You know, the idea of brute force, being we're forcing ourselves in, is sort of used with both. So keep that in mind if you go for a cert exam. So a hash manager can hash passwords, every combination of letters, numbers, and characters. That's a brute force attack. It's very slow. Masking attack, rule attacks, and so on. Understand that different attacks can happen again against your site, and this will help you defend against it. So here's again, with some analysis, you can figure out mask attacks here, rule attacks, statistical analysis, and so on. Dictionary attack, again, pretty straightforward. I already talked about this. The birthday attack being there's two digests of the same. This is where rainbow tables sort of come in. It's pre-generated sets of candidate digests you can use. Usually very effective. You can feed it plain text passwords. You can create the table, get initial passwords. Hashcat is great at this, and it's definitely one of the main tools they use for attacks. John the Ripper, Hydra will use those too. So rainbow tables, definitely look at this. And password collections. Again, there's a lot of them out there. I showed you one already. Usually through SQL injection attacks. And the idea being is this, that it's hard now to have a unique password. Someone's probably used something close to it, or maybe even the exact one. Even if you roll your face across the keyboard, someone may have used that password. But the fact that you have something that is unique, it makes you harder to crack, and versus someone who has the word password 1234 in their as their password. It's easier to go back and crack through several methods. So, password security. Again, password managers are great. Protecting the passwords is very important. How passwords are stored is utmost importance. I talked about this already. It's authentications, using tokens, which is again MFA, access cards, and cell phones. So again, biometrics. I think I've got ahead of myself here. There are behavioral biometrics. I haven't seen this used too much. I think the problem is with any false positives, you could end up having more issues and more support issues that you do security. And geolocation, talk about that. So before we move on to this last part here, let's talk about, again, what can I use to find best ways to do certain things. NIST, again, being a great one. Search for passwords, NIST, SANS. I'm going to point out, though, OWASP, one of my favorite sites to use. They have these called cheat sheets. And put yourself in the position of being you're brand new, security engineer, and you're asked by a development team, okay, what's the best way we should store our passwords? We don't know. We're a database. I'm a DBA. I don't know. I know what encryption is, but what should I use? What's the best way? You don't have to not to come up with this new. There are some good cheat sheets you can sort of give to or talk through a DBA or a developer. Tell them what algorithms to use. Tell them where to look. The FIPS 142, PCI DSS. So if you have to apply to regulatory, definitely use their guidelines. How cipher modes, number generations used. Very important, randomness. Don't use this any kind of random function. And so on. So this goes through in depth. You can sort of pick from this and look at Azure Key Vault, Amazon KMS. So again, there's ways to sort of make sure you're using the proper technique. If you're using cloud, make sure you look at the Amazon's key management service for the cloud, Azure, for example. And so, and password authentication itself. How do we do passwords? Input validation cheat sheet for email discussion here. So what is this? Input validation. whitelisting and blacklisting. So we know about that. That's actually goes a separate topic. But we go through how do you properly ask for a password. There's a NIST link here. We should have a minimum length. We should have do we have a maximum length? If we do is set too low. I usually see why you need a maximum length, but how we store it, how we implement a recovery mechanism, and again, here we go. What's the best way to do a password recovery? And you find that they have the 3 questions. What's the 3 security questions? What's the best way to do this? Forget password services and so on. So again, I'm not going to talk through all this, but this stuff's out there, and you can see what's the best way to do specific things. And the idea is too is if they're a Java developer, there's best known libraries to use to do this encryption, and if your database, best ways to store that encryption. These exist for all platforms, so use those. If you're going to use in cloud, use what the cloud recommends. Separation of keys and data, and how to encrypt stored keys. So again, there's great stuff for these cheat sheets, and there's a lot of them. Here, look at this. Tons of cheat sheets here. I can't recommend this enough. Just do a Google OWASP cheat sheet series, and forgot password, there it is, file upload. There's a ton of stuff here. So you'll see me use these a lot in the face-to-face lectures or just reference. So again, you're not left holding the bag. You don't have to come up with how do we store passwords for our databases. You can definitely leverage OWASP as a starting point. If it's Microsoft database, we'll go to Microsoft, look for their best practices. And really, you don't think of something new. Don't create your own encryption. Use best practices. Use well-proven, NIST-approved encryption. So, single sign-on is great. This is going to bring some easy use. Example: if you sign into your college main portal and you click on like eLearn, in our case, our shell, and it brings you and logs you in directly. Just make sure though how this is done. Single sign-on does have some stuff. It reduces the need of a different username password for different systems, which is great because if you force too many different passwords on their end users, whether internal or external, they're going to end up having easy passwords because I need to have 4 passwords for this college, let's say, or this institution. I'm going to create an easy one for the shell, an easy one for my own account access. You make it easier by having one single strong password and using single sign-on, OAuth, things like that. But these do have ways, so be aware if they're in place. OAuth, it's audited and it is set up and configured correctly. So Active Directory being a huge one, that's definitely the one place you'll see for Microsoft. Use those. If you have a policy in place that says you need to have a strong password, make sure Active Directory has policies that enforce that. So authentication, you can probably guess passwords is a big part of this topic. Just realize there are some other ways you can use sign-on, which single sign-on, and understand managing passwords and how to best manage those with a password manager, either given to by your institution or your own personal use. So I think I covered most of the chapter. That's chapter 11. That's authentication and account management. Hope this was helpful. Thank you.